The video today is the second half of our intro to logarithms. Yesterday we did just a basic how to change from exponential to logarithmic and how to change from logarithmic back to exponential. I want to remind you of what that is here. So I don't remember exactly what alphabet letters I use. I think I will better figure that out. Okay, here we go. So here's the back and forth. Log base b of y equals x. That's logarithmic form. And then b of x equals y is exponential. Okay, so reading the directions really matters in this lesson because you're gonna look at it, but you just got to make sure you really know what it's asking. So write it in exponential form. Do you guys want me to do the arrows or do you have it by now? 2 to the 5th equals 32. 12 to the negative 2nd equals a fraction, 1 over 44. Negative exponents equal fractions. (56 to the 0 power equals 1. The little number raised to the number after the equal sign. Okay, here we go. 5 to the 1st equals 5. What's the base if I don't see one listed? 10. So write a little 10 in there if you want. 10 to the 3rd equals 1,000. And did you guys know that there's 3 zeros because it's to the 3rd power? That was something from like scientific notation in elementary school. There's 3 zeros, that means 3rd power.
So if it was 4, then it would be 10.
Yes, 4 zeros. Lastly, G. Put a little 10 there as my base, please, for G. 10 to the negative 1 equals 1/10. All right. Now, without using a calculator, this is just, it doesn't have an equal sign. You have to figure out what's after the equal sign. If you want to put X, you can. 8 to the what power gives us 64? What number, 8, what? 8 to what power gives us 64? 2. You just write 2 as your answer. I don't even have to write X equals. Okay, ready? 9 to what power gives me 27? Ooh. Okay, here's the deal. I want 9, but I need to make it equal 27. So I need to figure out, like, let's see. It's going to have to be something bigger. Let's try 9 to the 3 halves. That means I'm going to go the cube root of 9 to the 3rd. The cube root of 9 times 9 is 81 times 9 is 729. Okay. What's the cube root of 729? Maybe that's 27. No. 9 to what power gives us 27? Let's do, this might be something for a later lesson because there is a way to do it, but I haven't taught you yet. 9 to the 1/3. Oh, it's square root. Oh my gosh. No, because, oh. Wow. Okay. Thank you, sir. Ready? Square root of 9 times 9 times 9. Oh, that is it. 3, 3, 3. Phew. 9 to the 3 halves. 81 to the x gives us something smaller. 81 to the 1/2, right? Because the square root of 81. 3 to the what gives us 1 over 27. 3 to what power gives us 1 over 27? How do I get a fraction? Anytime I want a fraction, how does that occur?
Negative.
A negative exponent. What negative is it going to be?
Oh, it's
Negative 3.
negative 3.
3 to the negative 3. You're right. Okay, now, these are the same type of things. 3 to the what equals 27?
Oh, 3.
3 to the third. So the answer is just 3. I don't even need to put x equals 3. And the reason why 3 to the third equals 27. Okay, 4 to the what equals 1?
0.
Yes, you guys, 0 exponents always make 1. 2 to the what equals 1 over 2. A fraction answer is made from a negative exponent. 2 to the what?
Negative.
Negative 1. Yeah. Okay. 8 to the, think guys, 8 to the third would be huge. But I like that you're thinking about 3 because 2 to the third is 8. So there's a 3.
1/3.
1/3.
That's what you do.
Good job. Okay. What? 5 to the, there's a rule where the 5s cancel out because they're in common, but we're going to do that later. Skip number 14. Okay. You guys, NA, you cannot get a negative with a log.
So that would be no solution.
Right, no solution. No logarithm is ever going to come out as a negative answer. So 15 you cannot do. Okay? So, you guys, some of this is like on repeat. I'm going to skip right here. Okay. Did you know that you have a log button on your calculator? It's a value. So go to your calculator, press the log button on top, and then press 11.5. All right. Press enter. That is the value of log 11.5. So sometimes you have to just enter it straight forward into the calculator.
How do we put it into? You just put log and then 11.
You type in, you push the log button on your calculator.
11. Oh yeah.
So that's it. That's all you do. Those are easy kind because the calculator tells you the answer. Okay, now we're going to learn how to solve, which again is still the exact same thing you did yesterday. Yeah, but come get it. Okay, I'm going to skip number 1 for now. Okay, because we're just going to do basic straightforwards. This says log base 10 of 2x plus 3 equals 4, right? It should be base 10. So you're going to write 10 to the 4th equals 2x plus 3. Same thing as you've done before. What is 10 to the 4th?
10,000.
4 zeros, right?
Would you solve that?
You would ready? 10,000. Yeah, solve for x. Move the 3 over. Okay, What is 10,000 take away 3? 909.
9,997.
9997 equals 2x. Okay. Easy, easy. Divide by 2. 4.
499.
Okay. It's the exact same method. The base raised to the power of the number after the equal sign. So here we go. This base is 10 because there's no number there. 10 squared equals 3x minus 2. 10 to the second power equals 3x minus 2. Add 2 to both sides. Just solve for x. And divide by 3. It goes in evenly 34 times. Do the last one by yourself. Okay. So, what'd you get? 2 to the 4th is what? Right? Just subtract 2. Good. Okay, so what I want to do is I want to go on Desmos and talk to you about these graphs because these are the last 3. We're going to talk about the domain and how, because we're not graphing, but let me get, here we go. Square root of, oh no, I can't get my, where's my, there we go. Okay, square root of x minus 4. All right, here's the deal. The domain means where does my graph start and where does it stop? So look at this. Okay, where does my graph start and where does it stop, guys? Starts at 4. So here's what you're going to do. And it ends. It goes on forever to the right. That's what log graphs look like, okay? So here's what you're going to write. The domain. And look, it's the opposite sign of what's in there. It starts at 4, bracket, and it goes to positive infinity. Okay? All right. Now let's go back. Next one. Yeah.
Oh, never mind. Sorry.
Okay, next one is cubed root of sorry. Oh, bummer. How do I do cube root?
The B or
Oh no.
What are you trying to find?
Cube root on Desmos. Here we go. Ah, whoa, 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 whoa.
Square's right there. Oh, right.
Okay. Cube root of x, get out of the radical sign, minus 2. Woo. Fun. Look at that. Okay. So this is going to be all all real numbers, negative infinity to positive infinity.
Could you do the sign?
Huh?
Could you do the sign like
The R,
the line?
negative infinity to positive infinity. Okay? But the point is with logs, let me give you another one. Let me change number 3. Log of x plus 5. Let's try that. Can I zoom? There. Okay, let's go to Desmos. Maybe I can type in log. Base 10. Okay. So what's going to happen? Let me make sure it doesn't change with. And let me do a second one. Log base 5 of x plus 5. Okay, check this out. It really doesn't matter what the base is. What matters is what's in parentheses. So I did log base 10, x plus 5, and I did log base 5 of x plus 5. This straight line, this is what we call an asymptote. It's never going to go to negative infinity. It stops at 5, and it gets super close. It looks like it touches, but when we zoom in, we'll see that it doesn't touch. So your domain for this is going to be at 5 and then positive infinity. Because the graph starts at, negative 5. Negative 5, right?
Do you have to do closed brackets?
It never touches, so it would be a parentheses. So let me go back to my screen. Ready? Parentheses. Negative 5 to positive infinity. Okay? So, what you're going to do is you're going to start on number 7 for homework, classwork, you can get it done. I whited out some, and you're going to finish on the back. Okay? Can you add this to a problem? We need to do solving one. Ready?
Log S? Or no?
5.
Let's see.
Those are 2 that I'm adding to your, because I want you to practice just solving. 7 to the back.
Is the video end?
All right, I'm going to stop the video. Easy, right, guys?